Hello everyone, welcome back to Math with Allison. Today we're continuing our series on derivatives. So specifically we are talking about how to take the derivative of inverse sine, cosine, and tangent. So let's go ahead and dive into it. First question of the day, what is inverse trigonometry? So if we have our example right here, y is equal to sine of x, how are we going to isolate x? Because remember, whatever is inside the trig is going to be the angle. So what if we wanted to find the angle? And the way that we do that is by taking inverse sine of both sides. So if I take inverse sine of y, I can also take inverse sine of our other side, right? So sine of x. And what happens here is that basically they cancel each other out. And so these two cancel out and we're just left with x on the right side. And now we have sine -1 or inverse sine of y is equal to x. And so that's how we'd be able to isolate the angle, whatever degree or radian that is. So how do we find the derivative of this? We want to find y prime when y is equal to the inverse sine of x. And we are actually going to use a very similar process. So what I'm going to do is take sine of both sides. So here I get sine of y is equal to, and when I take sine of inverse sine, they cancel out and you're just left with the inside. So now we have sine of y is equal to x. Now we're going to go ahead and use implicit differentiation. So I'm going to take the derivative of both sides in terms of x. Here we want to take the derivative of sine of y. When I do that, right, I can take the derivative of the outside. So here I have the derivative of sine is cosine of y. But remember, in chain rule, we have to multiply by the derivative of the inside. So when I take the derivative of y in terms of x, that's not a thing because they're different variables. So I'm just going to leave it as the first derivative of y, or y prime. And so now we're going to go ahead and take the derivative of the right side, and here I get the derivative of x is just going to be 1. Another way that we could have done that is by using chain rule explicitly. So I say u is equal to the inside, so that's y, and then g of u is going to be the outside, so this becomes sine of u. When I take the derivative of both of them, I get u prime is going to be equal to y prime, right? And then g prime of u is going to be equal to cosine of u. When I multiply those together, I get y prime times cosine of u, plug u back in, which is y, and that's going to get at the same answer. So you can do it either way, it gives you the same value. But remember, we're trying to solve for y prime. So if I divide over that cosine of y, I get y prime is equal to 1 over cosine of y. Now here we're not quite done because I don't want this to be in terms of y. I want my derivative to be in terms of x. So how am I going to replace this cosine of y with something in terms of x? And actually what we're going to use here is the Pythagorean identity. So sine squared of y plus cosine squared of y is equal to 1. Here I can go ahead and solve for cosine. So I'm going to subtract sine squared of y on both sides. So I get cosine squared of y is equal to 1 minus sine squared. I go ahead and take the square root of both sides. So here I just have cosine of y is equal to the square root of 1 minus sine squared of y. But one last step. If we go back up here, we can remember what sine is equal to. We have sine of y is equal to x. And so I can replace that right here. This becomes x squared. So when I do that, I get cosine of y. And now I can go ahead and replace this back into the equation. So we have cosine of y is equal to the square root of that, and I'm going to replace it right here. And here we have our general derivative of inverse of sine. So when I write that out, I get 1 over, and in the denominator, we have the square root of 1 minus x squared. So let's go ahead and see this in action a little bit. Our example here, we want to find y prime of y equals inverse sine of 2x squared plus 1. So what happens when we change the inside? Let's go ahead and apply chain rule. So we have the inside is going to be whatever's inside the parentheses, so 2x squared plus 1. And then our outside is going to be g of u, and this will be inverse sine at u. Alrighty, let's go ahead and find these derivatives. So I know u prime is going to be equal to 4x. And now we get to use our rule in order to find g prime. And that becomes 1 over the square root of 1 minus u squared. So I'm going to go ahead and use these to find the derivative. Y prime is equal to u prime, so 4x, times g prime. that is 1 over the square root of 1 minus u squared, but I want to go ahead and replace what u is equal to. So I get 2x squared plus 1. If I want to simplify this up a little bit, make it look kind of nice, I got that 4x in the numerator, and then I have that exact same denominator. And that is our solution. So this is how we can kind of use that in action. So we are going to do that exact same process for inverse cosine. So let's go ahead and dive into it. I'm going to take cosine of both sides. So here I get cosine of y is equal to x. Now again, I'm going to go ahead and use implicit differentiation in order to find the derivatives of both sides. I'm going to explicitly write out chain rule, so I have my inside is equal to y, and my outside, g of u, is equal to cosine of u. When I find these derivatives, I get u prime is equal to y prime, and I get g prime of u is actually equal to negative sine of u. So when I plug these in, I get y prime times negative sine of y is equal to the derivative of x, which is just equal to 1. Okay, so remember we are trying to solve for y prime. So what I'm going to do is divide over that negative sine y. So we get negative 1 over sine of y. But again, I don't want to have my answer with y in it. I want x in it. So again, guess what I'm going to use? I'm going to use that Pythagorean identity again. And so again, I'm going to go ahead and solve for sine here. And now again, we can use the original problem. So here I have cosine of y is equal to x. So now I can replace cosine squared with x squared. So now when I replace this back into y prime, I get y prime is equal to negative 1, or that negative can be out front. Doesn't really matter where it is, multiplication is commutative, over the square root of 1 minus x squared. And this is our rule, so it's very similar to inverse sine of y, but it's just going to be negative, just like how the derivative of cosine is negative. So when I plug this in, I get negative 1 over the square root of 1 minus x squared. So let's go ahead and see this in action. So we want to find y prime of y equals sine of inverse cosine. Let's go ahead and use chain rule explicitly. So I have u is going to be inverse cosine of x. My outside g of u is going to be sine, and that will be sine at the inside. Let's go ahead and find our derivative. So u prime, and now we get to use the rule. So this becomes negative 1 over 1 minus x squared. And now g prime of u is going to be a regular trig rule, so we get cosine of u. Let's go ahead and plug this all back in. So y prime is going to be equal to u prime, which is negative 1 over 1 minus x squared. And I'm going to multiply it by g prime of u. So I get cosine of u, plug that back in, I get inverse cosine of x. But remember what we talked about earlier, the cosine of inverse cosine cancel each other's out. And so I'm just left with an x in the numerator. And so now I get negative 1 times x, which is negative x, all over the square root of 1 minus x squared. And that is our solution. So we have one more here. We want to find y prime of inverse tangent. So guess what? We're going to do the exact same process. First, let's go ahead and rewrite it. So I'm going to take tangent of both sides. So I get tangent of y is equal to x. Again, we are going to use implicit differentiation. I'm not going to write out chain rule explicitly. I'm just going to use what we have in the past. So I know this becomes y prime times the derivative of the outside. So the derivative of tangent is secant squared at the inside. And now the derivative of x is just going to be equal to 1. I'm going to divide both sides by that secant squared so I can get y prime all by itself. And I get 1 over secant squared y. So if you can take a wild guess, we're going to be using that same formula. So we have sine squared y plus cosine squared y is equal to 1. And I want to get tangent in there somehow. So what I'm actually going to do is divide every single term by cosine squared. So when I rewrite this, sine squared divided by cosine squared is tangent squared. And now I get plus 1 is equal to secant squared y. And if we remember what we have here, we have tangent of y is equal to x, which means I can replace this tangent squared y with x squared. So I get x squared plus 1 is equal to secant squared of y. And if I were to plug this back into what we have in the denominator here, I get 1 over x squared plus 1. And so this is our rule now. We have for inverse tangent that the derivative is equal to 1 over, and some people write it as 1 plus x squared plus 1. They're the exact same thing since addition is commutative. But let's go ahead and see that rule in action. So here we want to find y prime of x times inverse tangent of x over 2. So first what I'm going to do is set up product rule, because we have x is our first thing, and then we have inverse tangent is going to be our second thing. So I'm going to go ahead and set that up. Alrighty, so let's find f prime because that one's nice. I know the derivative of x is just going to be 1. Now, if I want to find g prime, then I'm going to have to use a little bit of chain rule. You can write it out explicitly or you can just go for it. I'm just going to write it out. So I know my inside is going to be x over 2, and my outside, g of u, is going to be the inverse tangent. Alrighty, let's go ahead and find these derivatives. So u prime is nice. That becomes 1/2. And now g prime of u, that's going to be a bit interesting. So this is our rule that we have, 1 over u squared plus 1. But when we plug this in, we need to replace u back in. So I get 1/2 times 1 over, and now I get x over 2 squared plus 1. So let's go ahead and we have product rule laid out very nicely for us, and we're going to go ahead and use that. So y prime is equal to, and we'll start at our bottom, work our way to the top. So I get 1 times inverse tangent at x over 2. I'm going to go ahead and add the other cross. And so I get x times 1/2 times 1 over x over 2 squared plus 1. So when we can simplify this out a little bit, so I can rewrite this as inverse tangent of x over 2 . And there we have arrived at our derivatives. If you enjoyed this video, I have many more like it, so make sure to check them out. I have the playlist link down below. Otherwise, thanks for watching the video. If you enjoyed it, please leave a thumbs up and comment other topics or problems you'd like to see done. Thanks for watching.